So this situation is closely related to the one we had before. We now have an intersection on the outside again, but it's just a tangent and a secant. So if you look at the relationship before, it was the whole thing times the external. And that's still going to be true for the secant part. It's still going to be that whole line. So ED, whole was in blue before. ED times the external in green, which is EC. So we've still got ED times EC. And you're probably starting to see the issue that now our whole is the external. Okay, so I can't do exactly what I did before, but if I know that the whole line is also equal to the external, I can trust that, and that relationship will hold true, that it's EA times EA. Now, if that's a little bit confusing, face is flashing. If that is confusing, because it is, what you can do is you can rewrite it as ED times EC is equal to EA squared. So again, either way works, and that is because we don't actually have an internal for that other segment there. So if a secant and a tangent intersect outside the circle, the product of the length of the whole secant, so the whole was in blue, multiplied by its external part is going to be equal to that whole tangent segment squared. So again, it's that whole thing and it's squared. But if squared is confusing, you can multiply it. You can just treat it as being multiplied by itself. Okay. So if we use that relationship right now, we've got our whole and our whole down here. And then we have our external 18 and our external 24. So I'm going to do my whole, which is 18 plus x, times my external, which is 18. That's going to be equal to my whole, which is 24, and my external, which is also 24. So again, you can write that as 24, 24, or 24 squared. I'm going to move my work down here below the circle, which is probably where I should have started, but that's okay. So I'm going to distribute on top to give you 324 plus 18x. That's equal to 576. Now solving for x, I'll move that 324 to both sides, giving me 252. And the last thing is I'm going to divide by 18 on both sides and get 14. So again, the relationship here, the weird part is that the 24 is the whole and it's also the external. So again, if I label with colors, my whole is 16 plus 9. And my external is just the 9. And then my whole is x, which is also my external in that situation. So I'm going to have x times x. And that's going to be equal to 9 times 9 plus 16, which is 25. When I multiply those together, I get 225. That's equal to x squared. Remember how we get that 2 out of there? Getting that x alone, we got to square root both sides, giving you that x is equal to 15. So again, there's 3 relationships here. One is a secant and a tangent, and that's where you have to do the squared part. One is 2 secants, and that's where it's just whole times external equals whole times external. And then the last one, or the first one, however you want to look at it, is when it's 2 chords on the inside, or 2 secant lines. 2 secant lines could make the situation, and it's just the 2 parts of the same chord multiplied together equal the other 2 parts of the same chord multiplied together. Stick around for more videos. Hopefully they're helpful.